Do you use Yara for threat hunting or forensics? If yes, then awesome. Stay tuned. We'll show you exactly how you can leverage that within AI Query to simplify that process. But if no, even better. So, if you're not familiar, Yara uses rules to scan files, memory, processes, etc., for specific patterns that may indicate the presence of malware or just suspicious or undesirable content, which makes it excellent for identifying attributes common about binaries rather than simply hash matching, since it's slightly more difficult to change than just mutating a hash. So, with that said, let's show the power of Yara and how exactly you can leverage it within AI Query. All right, so let's hop right on in here. So we have our selected target device where we saw abnormal activity that we want to investigate further, and we've given it a title because what we want to look for here is Mimikatz. So if you actually had a Yara signature that you composed yourself, or maybe that you got from several different third-party locations or something of that nature, since it is open source and there are tons of great resources out there, you could always just write your own query, select star, specify the path, and then the Yara signature, good to go. But I do not have that, and I want to kind of showcase how AI can help you come up with those actual signatures and capabilities, whether it's proactive or retroactive. So what we want to do here is say use AI. We are AI query after all, and then it'll open up QuerySmith for us here on the right hand side. We're going to go down select mode, which again is kind of for tailoring to specific use cases for heightened efficacy. In this case, we're going to specify attack rather than technique ID, which uses MITRE technique IDs, which we've shown in a prior video. This one we're going to use Yara rule. And then we want to give it the context for what to look for. So we'll say Mimikatz binary header info, and then say Windows downloads directory, and hit generate. So while that's thinking, we'll pop on over to OS Query, show you the actual Yara implementation within OS Query and the table right here. And so what you can see right here is it requires one of these sig group, sig file, or sig rule. So since we're just using it in line, we're going to use sig rule, and that's what AI is going to create for us. And then the other requirement, which is why I specified the Windows download directory, is this path right here, as it needs to know where to actually perform this scan. So AI will actually generate what they believe to be the best path. You likely would want to specify operating system, but even in general, it'll generate the best path, but it tends to be very broad, which is intentional. Scan a large path where it could potentially hide. But for the sake of the demo and expediency, that's why I specified the downloads directory. So let's pivot back on over to the console, and we can see we already have a result, which is awesome. And let's check out what they generated for us here. So they generated a binary header string, which is great. So right there, that should be the header associated with Mimikatz. So that's what we're looking for. And then what we want to do here is go on ahead and add in a few additional capabilities. So let's say join file table to include file name, and UID, and hit refine. So the one kind of downside about the Yara table is it only has a limited number of actual results. It's going to give you the path and say, does this match and how many times does this match? And that's effectively it, which is super helpful, don't get me wrong. But the benefit and power of OS Query and utilizing Yara in this capacity is that you can join any one of these tables as so long as they share a common field or column, which in this case is going to be path. So we'll pivot back over. We can see Refine has already added that further context. So we can see right here from Yara inner join file on file path, and then it adds the file name and the UID. I could actually iterate one more time and actually add the username by joining the users table now. But again, that's really the power of OS Query. You can take this disparate but helpful information and then combine additional information on top of it to provide further context. So we'll hit accept. The last thing we want to do is let's make this recursive for downloads. I could ask AI to do it, but just easier to have the recursive wildcard. And then we'll hit execute. And then we'll pop on over and check out the results. So here we have it. Again, it's a scan, so it tends to take it slightly longer than like the few seconds it normally does, but it's still very quick. So we'll hit refresh, and right there we already have a result. And right here, awesome, we can see the matches and the file names on the matches. Sorry, I meant to filter on matches right there. And so right here, we can see everything that has the Mimikatz binary matches, which is awesome. So kind of awesome, kind of not awesome, because we confirm that there's Mimikatz in this environment. But what we can do, and another reason that's helpful for threat hunting and forensics, is now we have this information that exists on the machine. So we know that the signature is able to identify it and also not identify a few other items like iCar or OS Query. So it may not identify every attribute. We may want to tweak and tune the actual Yara signature itself. But for now, we know that it does get a decent portion of the actual Mimikatz binaries that we're looking for. And so what we'll do is we'll hit Query Overview, Edit, and Run. and then we'll remove my machine right here. We'll go over to agent groups, logical groupings of machine, and select all Windows machines within our environment. Give it a title, say across environment. If I could spell, that'd be nice. And then we'll execute it. So then we'll pop on over, see the results, and we can see one agent group. If we hover on over, we can see 4 pending results. If we refresh, we should get that updated. And so we already have a couple responding. The responses are relatively relevant. This is a demo environment. I know I don't have this on the other machines, but the larger point is to say, okay, hey, we saw something in our environment. Let's create a Yara signature for how we can identify it. Boom, we did. We confirmed the abnormality that we saw. Now let's take that, do some threat hunting or digital forensics, whether it's trying to proactively assess where else it could be lying dormant in the environment, or whether it's identifying a potential scope of a breach and seeing, okay, did this proliferate to any other nodes that we may actually need to rectify? We can answer that question in just 2 seconds by running that query across the environment. We could also save it for future use. And then, of course, last but not least, we could go to live shell and then remove those files on that device. So that's kind of the full workflow of how aiquery leverages Yara and can help improve your overall security processes. Hopefully that was helpful. And thanks. Check y'all next time. Bye.